Hello, today we are going to talk about writing verbal and numerical expressions. First, let's define what verbal and numerical expressions are so we know what we are being asked when the time comes. In our last video, if you happen to watch it, we talked about the word variable and that a variable is an alphabetic term, number, letter, used to represent a value in a mathematical expression and or an equation. Evaluate means to find the answer. We're not going to evaluate in this lesson, though. We are just going to write the expressions. So a verbal expression, using verbs, using your mouth, talking out loud, it's an expression written as words. Verbal, something we can read, words, verbal expression. An example of the verbal expression is 2 plus 4. This is written in words. A number increased by 2 is written in words. I can say that to you with words, write it out. A numerical expression takes these verbal expressions and actually puts them into numbers instead. So here it's a numerical expression, 60 plus 25, written only in numerics, numbers. 42 divided by 7, same idea. Verbal expressions can be translated into numerical expressions, and that's what your job is going to do. This lesson is called Writing Expressions, and you are going to take verbal expressions and turn them into numeric, and numeric and turn them into verbal. Why don't we move forward and try some of these? First, can you quickly tell me what the difference between these are? Numerical expression is a what? Algebraic expression involves what? Hopefully, you were able to come up with something related to that. Has numbers for numeric and a variable or letters for algebraic. All right, so down below we have a few expressions here. An expression simply does not have an equal sign. That's the easiest way to explain that. It just means that we have some values here that we need to put in here. So let's see. Numerical, algebraic. Numerical, algebraic, numerical, algebraic, numerical, algebraic, numerical, algebraic, numerical, algebraic. Which of these go where? Well, remember, numerical contains numbers only. This has numbers only. There are two others. Can you figure out which two they are? Which leaves the rest to be algebraic. A letter D, letter X, and another letter X. Those are all algebraic. All right, we're going to skip that slide and we're going to go right in here. These are all the same way to say this. 9 more than a number. Oftentimes in class, the question is, well, what number are we talking about? And in a variable, it doesn't matter. All I know is that I'm taking 9 more than that number. You have to be careful with some of these. However, more than is usually a good reference to mean adding. The sum of 9 and a number. The sum, a number plus, a number increased by 9, and this is very critical here. In this case, the word number came first. So my number came first. That isn't always the case, however, so let's just be careful in understanding what this means. And then the total of x and 9. The total of x and 9. We typically don't see this one because it's deceiving. However, if I want the total group, adding is usually what we want for that. All right, so let's look and try and decide what these next ones are. 4 subtracted from a number. I always like to put something in place of this because students, this is the one they will get wrong most often. 4 subtracted from, and I like to think about putting in the word here, my age. Because if I asked you right now to say 4 subtracted from your age, most of you, because of how old you are, most of you are going to come back with a number related to, let's say 8, maybe 9, of how old you, of what that would be. Because you started with your age and you subtracted 4. So if I want to take 4 subtracted from a number, I need to start with that number first and subtract 4. Again, all of these should say the same thing. A number minus 4. A number minus 4. 4 less than a number. In order to take 4 less than a number, I need to know what that number is first, which tells me the x comes first. A number decreased by 4, and then its vocabulary term of difference. All right, and so I never revealed that. Let's reveal it. We were right. Okay, so 6 multiplied by g, 6 times a number. The product of g and 6 are a few ways to say this. Now, mathematically, this is why we can't write times with the x symbol anymore. Because if I write times with the x symbol, and we're working with variables, this looks like 6xg, not 6 times g. So this right now is a big no-no. We don't want to write this anymore. We can write it as 6 times g, 6 times g, 6 times g. They can both be in parentheses, but no longer can we use the x since we're dealing with letters, variables, in our other problems. A number divided by 5, a quotient of t and 5, divide a number by 5. These are all the same ways to say that. All right, so I'm going to give you a minute. I want you to hit pause, and I want you to answer as many of these out as you can. All right, thank you for hitting pause, solving. Let's see how you did. Let's look at some of our key words here. 5 plus a number d. It's telling me that the number is d, and I want to take 5 plus that number. So, because of the commutative property, you can write this one either way, because the commutative property for addition states that it doesn't matter the order. The product, product is one of those words we typically have some trouble with. Product means to multiply, so in this case I'm going to multiply 5 times g. Next one, 11 fewer than the number f. I want to take 11 fewer, 11 less than. 11 subtracted from a number f. Well, in order to do that, I need to know what the number f is first, and then take 11 away from that. 17 less than h. Well, I need to start with h in order to take 17 away. The biggest catch when you're trying to work on these problems is to realize that you cannot just write it in the order that you read it. You will get that wrong. You have to think about it logically. And like I did in the last example, if I wanted 11 fewer than my age, I would have to start with my age and subtract 11. 17 less than my age, I would have to take my age and add 17. Quotient. Quotient is another one of those words that we don't always think about, but it means to divide. And I'm going to take 20 divided by t, the quotient of 20 and t. Notice that these are all expressions. None of them equal anything yet at this point. We're going to take time to learn how to write expressions and then later equations. All right, so here we go. 7 less monkeys than Michael. I have 7 less monkeys than Michael. So what do I need to know? Well, I need to know how many monkeys Michael has first. So I'm going to start with M. Whether it's for Michael, whether it's for monkeys, I'm going to make it stand for Michael. And if I have 7 less monkeys than Michael, I need to take monkeys and subtract 7, and that'll tell me what I have. M minus 7. I don't know if this is going to work. Let's see. There it is. All right, M minus 7. Does the variable matter, however? What if you decided to write x just because you like that? Again, any variable stands for a digit and a value, so it doesn't matter which one I choose. So if you had x minus 7 and my answer said m minus 7, you're still right. That doesn't matter. You're still safe with that. I have 5 more cookies than Candace. 5 more cookies than Candace. So what do I want to know? I want to know how many did Candace have. I'm going to add 5 more to that, and I'm going to figure out how many I have, because it's 5 more cookies than Candace. Now, yes, there are some other ways that you could look at this. I'm not even going to write them down to confuse you right now, but I want just to have 5 more cookies than Candace. So I'm going to take Candace's cookies plus 5. Notice their answer is backward compared to mine. It's in a different order. However, commutative property says that's okay. You try these two and then come back. Hit pause, come back. All right, welcome back. Here we go. The number of napkins divided by 2 people. Here I have the napkins. I'm going to divide it by 2 people. Yes, we can still use the division symbol, but I would rather you get into the habit of using the fraction bar. Get into the habit of this fraction bar. All right, 9 times the number of kangaroos. Why do I need 9 times the number of kangaroos? I don't know where we come up with these examples. However, that's what I would do. 9 times the number of kangaroos. Could I put K9? I absolutely could. There would be nothing wrong with that, other than mathematicians are a little particular, and they want the coefficients in front of the variable. All right, so now we also have to practice writing word phrases. Most of the time, students take what I like to call the easy way out, and they write the easier vocabulary word for all of these. So rather than saying, which I could, the sum of a number and 5, most kids would just write 5, whoops, not like that, sorry, 5 plus a number. We could also say, this is what we get most of the time. However, I could say a number increased. Uh-oh, you can tell I'm trying to write fast when the cursive kicks in. A number increased by 5. A number increased by 5. So let's you try this next one. And be careful, because that can be a tricky one. All right. You could very simply say 3 minus a number. This is true. Very simply, you could put that. Or you could say a number less than 3. Or a number taken away from 3 wouldn't quite make sense. That would be like very bad vocabulary or grammar, excuse me. So a number less than 3. Something to that extent. A number divided by 5. The quotient of a number and 5. And then here, 12 times a number. The product of a number and 12. Something along those lines. Finding and writing expressions usually is not very difficult. We might throw in a kicker once in a while, and we might say something along this lines. So you have 2 happening at the same time. Now this is multi-step, and we'll talk about it a little later, but it doesn't hurt to touch base with it right now. This could be something like twice a number plus 3. It might also look longer and say the same thing, where it could say the sum of twice a number and 3. Notice there are many different ways to say this. So just kind of keep that in mind as we go forward. Writing expressions is kind of a fun lesson. It's pretty easy, but it's a great way to get your brain to wrap itself around the different ways that we talk in mathematics. It's the mathematical language. One activity you could do for yourself is to create a note card like this. And your note card, ignore this word here because these all are just supposed to be placed somewhere. But your note card could say all the different ways that we could say the words adding, subtracting, multiplying, and dividing. All of these mean these different things. And you'll find even more as you go on. Below sea level, above sea level. There are many different ways to say how to add and subtract, multiply, and divide. These are some common ways, but you never know when you're going to run into those that I just said, or they earned a credit, there was a debt, they withdrew money. they deposited money. Those are all different ways to say adding, subtracting, multiplying, and dividing that you'll come across. So think about some of those other words and maybe start to create a note card that'll hold all of these for you so you can access them as you're going through your work. All right, thank you once again and have a good day.